Good afternoon, everybody. Welcome back to Roswell here for a trigonometry lesson. Now, y'all, I'm going to skip ahead just a little bit and talk about trig identities because I noticed that a lot of you have signed up for calculus next semester. And trig identities are a pretty big deal there. You need to know the graphing a little bit, but the trig identities come up multiple times when you're actually in the Cal 1 course. So I'm going to get to it right now. Now, the first thing I want to do is distinguish between just regular conditional equations and identities. Now, if you'll take a look at this one, this is a simple enough problem all the way back to intermediate algebra. It says 3x equals to 12. That's an example of a conditional equation that's clearly only true when x is equal to 4. So in other words, this equation right here, just by inspection, if you divide both sides by 3, get x equals 4. But, yeah, I'm trying this little lame writing function here in Zoom. So again, this is a conditional equation. It is not true all the time. It's only true when x is equal to 4. Now contrast that with this expression right underneath it. This is an example of an algebraic identity. Now we may not have called it that an identity in algebra, but it is an identity, meaning that no matter what values of x and y you choose, you're going to get the truth. Now, just as an algebraic exercise, if you do x plus y times x plus y, this is what you get. But let's just arbitrarily pick a couple of numbers. Let's say x equals 1. All right, x equals to 1, and then maybe x equals to, I don't know, 3. You want to try 3? Or y equals to 3? Let's do y equals 3. Y'all, these are arbitrary choices just to drive a point home. So if you put 1 and 3 right there, that's 4 squared, right? So this left-hand side would be equal to 16. Equal to 16. Now, if you go over here to the right-hand side, you put 1 in here. 1 squared is just 1. 2 times 1 times 3 is what? 6. 2 times 1 times 3 would be 6. All right. And then if you take 3 squared, that's 9. All right, y'all, I hope y'all are enjoying this as much as me. Okay, that's plus 1 plus 6 plus 9 is equal to 16, right? Now, I hope that's legible, y'all, but this is clearly 16 if you put 1 and 3 there and square it. And also, if you make the appropriate substitutions here, you get 1 plus 6 plus 9 is equal to 16, right? Okay. Now, what I want you guys to do, just to make sure you're watching these videos, is for the homework, your first homework problem will be just to pick homework problem number 1. We'll call it that. Homework problem number 1. Pick 2 other values of x and y and check this out and make sure you send that to me. Okay. You can pick any numbers you want. If you're smart, you'll pick smaller numbers. Pick numbers other than the one I picked. But again, pick 2 random numbers for x and y and send the confirmation that you know that this is an identity. Again, a simple homework problem. That's your first homework problem number 1. Okay. Now, the real purpose of today's lesson, though, is to work with trigonometric identities. Trigonometric identities. And so it's a process of starting with something there's a claim that this is true. Right here, this statement, they're claiming that cotangent theta plus 1 is equal to cosecant theta times the quantity cosine theta plus sine theta. Okay, where you can't assume that's true, you're trying to prove that it's true. There's multiple techniques on this. You can work from the left-hand side to the right-hand side or conversely. So y'all, what I'm going to do is I'm going to switch over to the doc cam right now, and we're going to work this one out. This very first one, I'm going to copy this down on the doc cam, and then we'll work through it together. Okay, it'll be just a minute because I have to switch. I have to stop this share and start another share inside of Zoom. Okay, y'all, I hope you see that new share right there. Now, So as you, this is, again, I just recopied this, and it's a verify. Now, this, we're trying to prove this statement. Now, what I did is I actually worked with the right-hand side first. All right, so I started with the right-hand side, RHS, that's not Roswell High School, that's right-hand side. Now, y'all notice that cosecant theta is the same as 1 over sine theta. So I just recopied this right here, okay? Again, this piece just got transported to here. And then if you use the distributive property of multiplication, this is what you get, this right-hand side, okay? Now here's where you have to remember that cosine theta over sine theta is cotangent theta, all right? And of course, sine theta divided by itself is just 1. So you see, that's a fairly quick proof. Now, y'all, I write QED for the proof right here. I mean, that we've concluded the proof, but you see how I circled these two? Or it's basically 2 steps. We rewrote this in terms of sine, then we used the algebra to distribute this through. And we have to remember that cotangent is the same as cosine over sine. Now, if you want to go all the way back, the cotangent is the same as the x-coordinate on the unit circle divided by the y-coordinate, if you want to think of it that way. But that's also the same thing as just saying cosine over sine. So y'all, just essentially 1, 2, 3 steps here, right? And we've shown that the right-hand side equals the left-hand side, okay? And again, QED, that's Latin quandam est demonstrandum, thus we have demonstrated. In West Texas, I would say we're done. All right, but this is a way to kind of write down your conclusion that you've finished the verification process. Okay. All right, now let's move on down. Now, the next one, or let me stop this share. Or let's see here, folks. Let me go to the back. So now we just solved that first one. Now we're going to go down to this second one here. Okay, this second one here, this guy right here. And again, I've copied that. I'm copying that on the document cam. This identity right here. Okay, so this is problem number 2 that I'm going to show you. So let's switch back. Okay, folks, here we go. Now, this one's a little bit longer. Now, I circled some relevant identity, and it's kind of hard to know you're going to need that until you get into the problem. This is not being worked out sequentially. I'd already worked it before I did this, obviously. But so, folks, let's just march through this. Okay, here we go. Now, I'm not saying my way is the only way, folks. Really, you may want to try go from right-hand side to left-hand side, but here, LHS, not Lubbock High School, left-hand side, I started with the left-hand side, and I rewrote everything in terms of sine and cosine. You see, tangent is the same as sine over cosine, so that's what I did right here. Cotangent is the same as cosine over sine, so that explains that. Okay. Now, if you'll take a look at this next step, this is one important step right here. I rewrote this like this, folks. Remember, it's just a common denominator problem where sine squared is kind of the default common denominator. Now, let me see if I can make this a little larger for you. Is that okay? A little bit bigger. I don't know if that's going to help. Okay, there we go. Now, so again, we're good right to here. We're working directly with the left-hand side right here, here to here. And now look at what's inside the parentheses here. It's this. And we can re-express this piece like this, right? Again, it's fairly easy to see sine squared over sine squared is just the 1 you see there. And we've gotten a common denominator out of the bargain, right? Okay, now you may go, okay, well, great. That looks more complicated than what we actually started with. But this is what makes these things kind of difficult sometimes. You have to remember all the way back when we talked about the unit circle, this is the first Pythagorean identity we did, see? And this identity, it's always equal to 1, no matter what value you choose for x. You could choose pi over 4, pi over 6, 30 degrees, whatever. And because of the fact that the unit circle is what it is, this is always going to be equal to 1. So notice when I go from here to here, all I did was replace this with 1, see? Okay. Now, another part that's a little sneaky here. We have this 1 over sine squared. Now, notice that if you go back up to here, well, I'm sorry, y'all. I left one thing out. This sine squared and this sine squared cancels, right? This sine squared and this sine squared is canceled, so we're left with this. Okay. Now you're thinking, how is this ever going to be equal to this? But if you go back to this identity, you can rewrite. You can manipulate this identity to get this statement right here. Cosine squared x is equal to 1 minus sine squared x, right? So you see, you just physically replace this with what it's equal to, and wham, these circled objects are equal to each other, okay? Now, I probably should have just worked this step by step. I was trying to save some memory on the storage, folks. These files get big. These Zoom files get massively large. But anyway, hopefully you're comfortable with this notion of proofs. We'll probably do a few more on the next meeting, or the next recorded meeting. It's not a true meeting. There's no interaction here. I can record these Zoom meetings and then turn them into videos, which is kind of cool. If I could just make this whole part work a little bit better, is getting everything on the same screen. Now, so again, we proved 1, 2 today, two identities. And what I want you to do, I'm going to give you your assignment here, and this will be just, you're going to have 3 total problems, the one I've already given you. Let me switch back, new share, back to the original document. Okay. What I want you, patient, kind human beings, to do is do these 2 problems for your homework. This will be this will be homework problem 1 right here. Homework problem number 1. Okay. And this one right here will be homework problem. I'm sorry, this is number 2. I've already given you that one on the first page, right? That's number 2. And this will be homework problem number 3. Remember, I gave you 1 is just the one where you're just plugging numbers into that identity to verify, right? Easy problem. Okay. So 3 homework problems. Y'all, this will be a file upload, not an email. And you'll see it all in Canvas. The due dates will be a lot clearer. And just a word to the wise, I know you guys have gotten better about this. If you're going to take pictures, that's how the majority of you are going to do it. I've gotten a few people who are doing PDF scans or some kind of thing. You can do it however you want. Most people are doing pictures. But if you have to take multiple pictures, be sure and drop those pictures into a Word document. Okay, and that'll be just 1 upload. There's been some concerns with people trying to, it only gives you 1 chance to upload. I'm going to switch that to 2 chances, but please just put everything in a single document. It's just better for you and me to have it all organized. I'll put a multiple upload on there in case something goes wrong, you can't find your stuff, or your stuff goes down or whatever. I'm going to do that. But again, this will be a file upload. This will be showing up for a Wednesday assignment. The due date will be Friday, but that'll all be indicated to you in the Canvas calendar, please. And most of y'all are being good about that, but this will appear in the Canvas calendar. It'll be uploaded as a quiz, but there'll be things you can click on in the Canvas calendar to take you right to where you need to be. All right, folks, that's it for today. I hope everybody's doing all right. It's kind of a chilly, sunny day here in Roswell. It was warm and windy yesterday. Today it's cold and not windy, so you can't quite get everything you want. But anyway, it's okay here. The COVID cases are fairly minimal in this part of the world, not a high population area. And I hear that everything's supposed to be flattening out a little bit. I don't know if that's just New York City or nationwide. But anyway, take care of yourselves, and we'll be back at you with another video before long.